Continuation of 10-1, Gauss-Jordan elimination. Okay, so we spent some time using Gaussian elimination. And by using Gaussian elimination, what that did for us is it gave us a main diagonal of ones. We had zeros underneath, and then we didn't care about anything else. Well, this Jordan guy gets involved and says, well, why don't we take this a step further and make everything above the ones and the below the ones zeros? And so what that does is it takes us from row echelon form to what's called reduced row echelon form. And so here's a system of equations. I've got 3 equations and 3 unknowns. And from that, I can generate an equation matrix. And from that, trust me, it's right. We do Gauss elimination, and we end up with this matrix. Okay, so all we've done so far is we've performed Gaussian elimination. My main diagonal is ones. Everything below the ones are zeros, and I don't care about the rest of it. From here, I can use back substitution, right? And I can solve for x, y, and z. We're now going to apply Gauss-Jordan and turn this into reduced row echelon form, meaning I want to get rid of that -2. I want to get rid of that 3. I want to get rid of that 3. I want those numbers to also be zeros. And we do the exact same thing we did to make these zeros. We work with these equations to eliminate these variables. Next slide. So here's where we are. Now apply row operations to obtain zeros above each of the leading ones. So go ahead. Do what? Then the whole row's gone. And that's a bad thing. Okay. So it's covered up under this box. It says perform operations on R1. So I want to do something to this equation so that the second column has a 0 in it. So how can I work with 2 of these equations to turn that into a 0? Parker? Okay. You can add 2 rows together. So you're saying you want to take this row and multiply it by 2? Okay, so if I took this row and multiplied it by 2, 2 times 0 is 0. 2 times 1 is 2. 2 times 3 is 6. And 2 times 5 is 10. So when I combine that row with these red numbers, you're saying that accomplishes the task, right? And that turns that into a 0. That's what I want, right? It's a method. We're solving a system of equations. Okay. So if I take 2, I'm going to write it up here. If I take 2 row 2s and add it to row 1, that's what you want to do. So 0 plus 1 is 1. -2 and 2 give us 0. 6 and 3 give us 9. 9 and 10 give us 19. Perfect. We took 2 of row 2s, added it to row 1, and that's what we received. Okay. So the goal is to make all of these zeros, and they already are, and I want all of these to be zeros. I still need to get rid of a 9 and a 3. So other than Parker, what can we do? Now this is now row 1, right? Okay. What can I do to get rid of the 9? Let's worry about it first. Let's get rid of that 9. Yes. Okay, let's see what happens there. Yeah, if I multiplied this by -3, would it turn that into a 0? Yeah, yay! But that's not going to be a 0 anymore. Boo. Can't do that. You can, but it doesn't accomplish anything. Any other ideas? Yes, sir. Multiply by 9? That would give me 18. Okay, so if I multiply this by -9, -9, that would be 0, 0, -9, -18. And if I combine those, I have a 1, I have a 0, then I have a 0, and I have a
1.
19 minus 10.
I thought you said that was 18. Because -9 times 2.
That is an 18. Okay.
You get
Okay.
1.
Nice. Like that. So I took -9, row 3. I added it to row 1, and I get 1, 0, 0, 1. Now I need to get rid of that 3. Absolutely. So if I take the bottom row and multiply it by -3, I get 0, 0. And if I combine row 2, -3 row 3s with row 2, I would get 0, 1, 0, -1. Y'all agree? Okay. Casey? Okay. Everything above and below the ones. The ones is the main diagonal.
And okay, so the top row that would be like your or the one. Okay, so the first column that'd be your x. So you're saying that x is equal to 1.
That's right.
The second or the second row would be that one is y. Y is equal to -1.
Okay, so these are.
Okay. Perfect. Yeah. So let me read this first line to you. 1x plus 0y plus 0z is equal to 1, meaning x equals 1. Second row, 0x plus 1y plus 0z equals -1. Therefore, y is -1. So z is 2. So we've solved the system. Casey? To check yourself? Sure, absolutely. Check yourself. Not a bad idea. Yes. So yeah, if you'll go back and watch yesterday's video, for those of you that left early, that shouldn't have. Not that anybody would do that. What we did yesterday was we solved it to this point. Once we get to this point, I don't know what x is because I've still got an equation. I don't know what y is because I still have a z, but I do know that z is 2. So because I know that z is 2, I can take that 2 and plug it in right here, which gives me 0x plus 1y plus 3 times 2 is 5. And then I can solve for y. And then I can take my x and y values, plug it into
this one, dot substitution. Because that is better if you go ahead and perform, reduce the echelon form, and you get the answer. So that is the solution. Now stop this setting and move into the setting. And it's not a